Welcome to qnawire.
We're shown this figure over here and asked to calculate what the direction of the current induced in the small circular loop inside the larger loop will be if the resistance in the resistor is increased over time. So if the resistance is increasing with a constant voltage, if we know that the voltage is equal to the current times the resistance, then if the resistance increases, the current must decrease proportionally, which means that the current, which is flowing counterclockwise, will be decreasing. This means that the magnetic flux, which is currently out of the page, will be decreasing. So to oppose this, the current flowing in the inner loop must create a field in the same direction of our original magnetic field. Namely, it must create a field out of the page because it's trying to keep the total flux through the loop constant. And if we curl our fingers in the direction of the magnetic field by the right-hand rule, we can see that this would correspond to a current that flows counterclockwise in the same direction as the original current. Part A. Oops. So counterclockwise. Now in part B, we're asked to consider the case now when our smaller loop is now placed to the left of our outer loop, with the current still flowing initially in the counterclockwise direction. So now the magnetic flux through our smaller loop, if we follow the right-hand rule of the magnetic field generated by the outer loop, we can see that at this point to the left, the magnetic flux is out of the page, or rather into the page. So the magnetic flux from the B field is fluxing into the loop here, which gives us a magnetic flux into the page. So now, to oppose this change in flux, which again is decreasing, the current generated in the smaller loop must be in the clockwise direction because this will generate a B field, or a net flux, out of the page, which opposes the change in flux generated by the outer loop. So in the second case, the current will flow clockwise in the smaller loop. So those are our two answers.